Hello learners, welcome to the quantum neural network session. So first we are going to think about what is a quantum neural network. So definition, as per the definition, quantum neural network combine principles of quantum mechanics with neural network to enhance the computational efficiency and learning capacity. We can have the advantages. We can go with the speed up of number of tasks compared to the classical neural network. Applications, we can have many things: optimization, pattern recognition, quantum chemistry, and big data analytics. Quantum neural network versus classical neural network. Definitely the processing unit is for GPU, and we can go for quantum neural network qubits. Computation deterministic here. We can go with the probability analytics is definitely needed to solve all kind of quantum neural networks. Feature space fixed and dimensional here, high dimensional, and speed we can go with the polynomial here, exponential for a certain task. Key components of quantum neural network. Qubits is very important for understanding the data in superposition. Quantum gates perform operation on qubits, and quantum circuit, sequence of quantum gates for processing the information. Measurement, quantum states to extract information. Hybrid model, classical and quantum layers for flexible architecture. Working flow, data encoding. Input data is encoded into quantum states using amplitude or phase encoding. Quantum layer, quantum gates manipulates qubits, certain entanglement and interfaces are there. Interferences are there. And hybrid layer, classical layers process immediate results in the case of intermediate solution from quantum layers. Next is training. Optimization, quantum parameters are also to be used with the help of quantum gradients or variational principles. The last one is prediction. Quantum measurements generates output predictions. Here we have the sample of data for 2 into 2 matrix, 1, 2 and 3, 4. Data points are to be represented as x1 and x2, and the amplitude encoding methods are to be used. Here encode x1 1 comma 2. Get x1 is to be calculated 1 by root of 1 squared plus 2 squared. Next is the value to be calculated for the encoding mechanism for x2 also, x2 which is equal to 3 comma 4. So get x2 also to be calculated. And next the quantum layer is to be applied for the third step. The quantum layer consists of applying quantum gates to the encoded states. Apply the HHs to create superposition. So get x1s to be calculated, and Hadamard matrix also to be calculated. So the final results to be calculated as get x1 is to be calculated 1 by root of 10, and get 0 plus get 1. So the final value for get x2 also to be calculated, h of 1 by root square 1 by root 25, and get 0 and get 1 also to be calculated for quantum layer. The next step is hybrid classical quantum layer. Here combine the quantum operation with the classical operation. Apply parameterized quantum gates, rotational gates with trainable parameters. Measure the quantum states to get output probabilities. Use classical optimization algorithms like gradient descent to minimize the loss function. So here the rotation function also to be applied for get x1. So cos of theta by 2 get 0 plus the sine of theta by 2 get 1. So measurement and output. Measure the final quantum state to retrieve the output probabilities which corresponds to the prediction values. So measure the get x1 resulting the probabilities of p of 0 and p of 1. And also we have to find out the activation function, examples of max. So advantages here is high dimensional feature mapping is possible, and with the help of Hilbert space for better features separatability. Next, exponential speedup is there, and noise um, we can easily control the system and enhance the learning power. Challenges is hardware limitation, and current quantum computation have limited qubits and high noise. Scalability, scalable application. This neural network is very suitable, but limited to the hardware. We have to think about the scalability. Optimization complexity is also there to train the required classical hybrid methods. And the encoding method, in quantum we can have many encoding methods are there. We have to choose the correct encoding methods to start the work. So thank you, learners. This is the information about neural network for the quantum computing. We will see in the next algorithm.